Okay, this is Mrs. Cribb again. This is the naming acids worksheet tutorial. And what I'm going to do is you should have watched the naming acids tutorial already. And so now this is to go over some examples with you. Pull up this worksheet, naming acids worksheet. It should have these on the front, and on the second page it have these. And the key will be sent to your parents, but it's at the bottom of here. So I'm not going to let you see that a whole lot because I do want you to get these done on your own. So what we're going to do is try to do a little bit of both types of questions. We're going to start with nitric acid. We're going to write the formula for these guys. So nitric. So remember atigitis. Ate, ick, ite, us. Ate becomes icks and ites become us's. All right, atigitis. So this is nitric acid. So because it ends in ic acid, I know it's going to be, first of all, it's going to have a polyatomic ion. So the ic becomes 8. So nitric would be nitrate. All right, so the ic would turn into an 8. So nitric would be nitrate. So nitrate, I have to go look at the polyatomic ion sheet, find nitrate, and there it is, nitrate, NO3 with a -1 charge. So let's write NO3 with a -1 charge over here. NO3 with a -1 charge. I'm going to put the -1 charge on top. Now, if I'm going to turn this thing into an acid, I have to put enough hydrogens at the beginning of this to cancel out that -1. Well, remember that hydrogen has a +1 charge. So this is a -1, so I only need one hydrogen to cancel out that -1. So one hydrogen and then NO3, that is nitric acid. The ic ending came from the nitrate ion. Okay, let's look at acetic acid. Acetic would be acetate. So we're going to have to go find the acetate ion. The ic would come back to 8. Atic itis. It always 8 becomes ic or ic becomes 8. Atigitis. So go and find acetate. On your chart, acetate should be close to the top, and it's a big one. C2H3O2. C2H3O2 and a -1 charge. So let's write that here. C2H3O2, and it has a -1 charge. All right, so how many hydrogens do I need to cancel out this negative ion? The hydrogens we're going to be adding, these guys here, we're going to add them to the front. And so maybe I should write those in a red color. We add those to the front. We only needed one of them to cancel out that negative. So that's the formula for acetic acid. It comes from the acetate ion. The acetate, which is C2H3O2-. All right, hydrobromic acid. Okay, now this is hydro something ic acid. It's not just bromic acid. It's hydro something ic acid, and that's a binary acid. Hydro something ic acid. So this is just hydrogen for the hydro, and then bromic acid is bromine. Okay, so HBr. Hydrogen has a +1 charge and bromine has a -1 charge. So hydro something ic acid is just hydrogen and the one atom. Okay, so what's the difference between this ic acid and this one? This one doesn't say hydroacetic, it just says acetic. So this is hydro something ic. That's that pattern, hydro something ic acid. All right, now we got sulfurous acid. 8 becomes ic, ite becomes us. So us would become ite. So sulfurous comes from sulfite, the sulfite ion. So let's go find that one, sulfite. All right, what do we have here? We have sulfate, SO4, so sulfite should be SO3. Okay, because per 8, ite. Ite is one less. 1 less than 4 is 3. Okay, so sulfite should be SO3 minus. And also, sorry, SO4 was a -2, so this is also a -2 or a 2 minus. I didn't write that correct. I double checked it just to be sure. So sulfite is SO2 minus. So this acid's made from that. I'm going to write the the ion part in blue, SO3, and it has a -2 charge. Now we're going to add the right number of hydrogens to cancel out the -2. Every hydrogen is a +1, so I'm going to need 2 hydrogens to cancel out a -2, because +1 times 2 would be +2. If I have a -2 over here, I have to have 2 hydrogens. If I have a -3 over here, I've got to have 3 hydrogens. So sulfurous acid is H2SO3. Okay? What about phosphoric acid? Phosphoric acid. All right, 8 becomes ic, so ic becomes 8. So phosphoric would be phosphorate. So I got to look for phosphorate ion. So I'll go look on my chart. Phosphorate or phosphate. PO4, phosphate. Phosphate's got phosphorus in it. So really it's phosphate. Some of those things you're just going to have to get used to the way they change. PO4 3 minus. PO4 3 minus. All right, so this is made out of PO4 3 minus. Okay, phosphoric. And now I've got to have how many hydrogens to cancel out? I switched my color code. Oh well. There are 3 negatives, so I have to have 3 positives. H3PO4, phosphoric acid. And it's made out of the not phosphate, but just the phosphate. Let's write it. Phosphate ion. My pen is too thick. All right, let's see. I'm going to do these 2 down here. Okay, hydroiodic acid. There's that pattern. Hydro something ic acid. So what's the something? It's the iodic, which stands for iodine. So hydro something ic acid. Hydro, H. What's the something? Iodine. Hydro something ic acid. That's all it is. HI. And it's, it's aqueous. It's in water. It's dissolved in water. Hydrogen iodide or hydro something ic acid. What about phosphorus acid? Adic-itis. Adic-itis. So ite became us. So us has to become ite. So I'm going to look for phosphite. This is that same thing. Instead of phosphorite, it's phosphite. I look for phosphite. Go find phosphite. I don't have it. I have PO4, so I need PO3 because 1 less than the 8 is the ite, and so that would be PO3. All right. So I'm going to look for phosphite, and I'm going to double check and make sure I write it correctly. It's PO3, and I'm pretty sure it has the same charge. Yep, PO3 minus 3. Yep. So go right back up here. So PO3 minus 3. It needs 3 hydrogens to cancel out that -3. Because we need 3 positives, so hydrogens are positive, put positive 1s, so I need 3 of them. H3PO3, phosphorus acid. All right, sulfuric acid is one of those you got to memorize. So I hope you're starting to get this. I guess I'm going to go ahead and do this one too. Sulfuric, ic becomes, so it's 8-ic-itis, so 8 becomes ic, so ic becomes 8. So adic-itis, I look for instead of sulfuric, I'm going to look for sulfate. It's got sulfur in it, sulfate. So look for the sulfate ion. So look at your chart, find sulfate. There it is, SO4 2 minus. So I'm going to write SO4 2 minus over here. That's the ion that's involved. And I have to have enough hydrogens to cancel out that -2. And every hydrogen is a +1, so I got to have 2 of them. H2SO4, sulfuric acid, one of the major ones that you need. Okay, so I did this many. I want you to finish the rest of those. And then over here, name each of the following acids. It's just the opposite. So let's just try a couple here. All right, it has a polyatomic ion in it, so it's going to do that pattern. 8 becomes ic. Ite becomes us. Adic-itis. So go look up ClO4. ClO3 is chlorate. ClO4 is more chlorines than, more oxygens rather, than ClO3. So remember the pattern, per 8. So the per 8 has 4 oxygens. The 8 has 3. So this is per 8. And it's per chlorate. Now we got to just change it into the acid words. That's the perchlorate ion right there. So 8 becomes ic, so perchlorate becomes perchloric acid. We always have to write the word acid at the end. All right, now here, this one, don't let this get you confused because there's a hydrogen right there and right there. This is the polyatomic ion, and this guy is the added hydrogen. Okay, so we need to figure out what is this polyatomic ion, COOH or CO2H. It could be listed in several different ways. So let's see if I can locate it. Oh, there it is, CHO2. CHO2, it's formate. So see, it can be listed a bunch of ways. CHO2 is formate. And let me double check that one. Yep, I like it when I'm right. So CHO2 is formate. All right, 8 becomes ic. So we got formic acid. Okay, do you see what we're doing here? H3PO4 was in the other one. That's phosphate, and that's phosphoric acid. All right, what about this guy? Binary acid. Remember, just 2. And binary acids have the form hydro something ic acid. So this is chlorine, so it's hydrochlorine ic, hydrochloric acid. All right. What about and don't worry about this one right here. Just omit that guy. Let's do this one right here. 3 atoms, so we must have a polyatomic ion. Let's go find CN. All right. Oops, not there. CN. There it is. Cyanide. CN. It's one of the ones you need to memorize. It's an important one. And so CN is cyanide. So this one's going to be different, right? Cyanide. We don't have an "ide" up here. So because it's written like that, I think this is just cyanic acid. And so it's one of the extras that sometimes don't follow all the rules, just like life. Nope, it's hydrocyanic acid. I told you, this one didn't follow the rules. Hydrocyanic acid. So be careful. I am not going to give you ones that don't follow rules on the test just because hydrocyanic becomes hydrocyanic acid. Just because I don't want you to worry about all the extras on these. I'm going to use the ones that follow the patterns. I figured that's enough for us. And the more we see them, the more we get used to the extras. Let's do 2 more of these guys. ClO2. There's the polyatomic ion. Let's go find ClO2. Well, I have ClO3, and that's chlorate. So what is ClO2? It's the one below 8. 8-ite. It goes per 8, 8-ite. Ite's below. So ClO2 is chlorite. So that's the ion I have to deal with. Chlorite. And so 8-ic-ite us. Ites become us's. So this is chlorous acid. And let me make sure that's how they named it down here. Chlorous acid. I may have misspelled it. CHLOROUS. Nope, I spelled it right. Okay, one more for this one. There it is. I'm going to do that one because it's binary. 2 atoms. These are the easiest ones. This follows the pattern. Hydro something ic acid. So there's bromine. That bromine is the something. So it's hydro bromine ic bromic acid. Okay. This is where I'm going to stop. Anything I haven't completed, you need to complete for homework and grade and correct it. See you later.